For angle proofs, we're going to have many definitions and theorems that we're going to use, and they'll be sorted and organized in a two-column proof. The first one is that if you have two angles that form a linear pair, then they are supplementary. That's your linear pair theorem. So if you have two angles that form a linear pair, such as 1 and 2, we would say that they are supplementary. Congruence of angles is reflexive, symmetric, and transitive. We'll talk about that down here. You'll see some of the same properties that we saw with our algebraic properties. Angles supplementary to the same angle or congruent angles are also congruent. So it's just saying that if two angles are supplementary to two other angles, then they're going to be congruent. And the same thing with complements. Vertical angles are congruent. If you're given a set of vertical angles and we establish that they are congruent, we would call that the vertical angles theorem. So what you may see would be a picture of a linear pair, and then if it says in one part of the proof that angle ABD and angle DBC are supplementary, then your reason would be the linear pair theorem. And just to highlight that, just to show you, this is your angle ABD and this is your angle DBC, and they form a straight line. So we would say that they're supplementary by the linear pair theorem. Okay, symmetric property, you'll see that with angles as well. So you may see in one line of a proof that angle 1 is congruent to angle 2. And then in the next line of the proof, you would see that angle 2 is congruent to angle 1. So all we've done here is we've flipped the order, and that would be your symmetric property. Transitive property, which you will see a lot with angle proofs. Let's just say you had angle 1 congruent to angle 2, and then they told you another set of angles were congruent, angle 2 congruent to angle 3. If you notice, the angle 2's are back to back, so we can conclude that angle 1 is congruent to angle 3, and that would be your transitive property. Remember, if the two terms in the middle are back to back, you're left with the first and the third. For example 3, you always want to look at the picture that you're given for a proof, and for example 3, we can see that angle 1 is congruent to angle 3. And the reason that angle 1 is congruent to angle 3 is, by definition, their name, the vertical angles theorem. And you can abbreviate angles by drawing the symbol for angles and theorem by writing THM. Okay, so right here we have the symbol for a right angle. So I could say that angle 1 and 2 are complementary. And the reason I know that angle 1 and angle 2 are complementary is because they put the symbol there for a right angle. So angle 1 and 2 are complementary. My reason would be the definition of a right angle, because angle 1 and 2 make up this right angle. I can go one step further because I've said that they are complementary. I can go one step further, and you'll see this in angle proofs. I can say that angle 1 plus angle 2 equal 90 degrees. The reason that measure of angle 1 and the measure of angle 2 equals 90 degrees is because now I'm taking the word complementary and I'm defining it. The definition of complementary says that two angles add up to be 90 degrees. That's the definition of complementary. And then finally, number 6, there's quite a few things we can do in number 6. We can identify that angle 3 is congruent to angle 4, and that angle 1 is congruent to angle 2. And our reason for that would be the vertical angles theorem that says if you have a pair of vertical angles, then they are congruent. I can also establish with this picture that angle 3 and angle 2 form a linear pair. So I would say that angle 3 and angle 2 are supplementary. And the reason that angle 3 and angle 2 are supplementary is by the linear pair theorem. Then if I go one step further and I say that the measure of angle 3 plus the measure of angle 2 equals 180, then I've taken the word supplementary and I've defined it. So that would be the definition of supplementary. Okay, now we need to look at our logic and reasoning skills. We're going to answer always, sometimes, or never, and then if it's sometimes, we'll come up with a reason why. If two angles are right angles, then they are sometimes, always, or never adjacent. Well, the answer is going to be sometimes adjacent. So here's the time when two right angles are adjacent because they're sharing a common side. And here's an example of two right angles that are non-adjacent. So sometimes they're adjacent, sometimes they're not. If two angles are complementary, then they are also sometimes right angles. So a right angle looks like this. If you have two angles that are adjacent and complementary, then they are a right angle. But you can also have an example like this, where you have two angles that are complementary, but they don't form a right angle. They're two separate angles. If two angles are congruent, once again, they are sometimes right angles. So you can have these two angles be congruent, and yes, they are right angles. Or you can have these two angles be congruent, but they're not right angles. Vertical angles are never adjacent. That means that they do not share one common side. They're not next to each other. They're across from each other. Congruent angles are sometimes vertical. So here's the time when you have vertical angles that are congruent, and here's the time where you have congruent angles that are not vertical. They just happen to have the same measure. And then finally, if two angles are supplementary, they are sometimes congruent. So you can have this situation where these two angles equal 180 and they are congruent. Or you can have this situation where you have two angles that are supplementary, but they're obviously not congruent. Alright, so now let's put it all together and look at an angle proof. When you're doing an angle proof, you're always going to need to look at the picture. If you can't find something that matches what you're used to, like transitive property or symmetric property, if you're kind of stuck, look at the picture and see if there's vertical angles in there or a linear pair. Those are usually going to be in the picture. So angle 2 is congruent to angle 3. Well, that was given to us, so that's our reason for why. And then they say angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4. So if I look up here, angle 1 is congruent to angle 2. Well, why are those two angles congruent? Because they're vertical. So your reason would be the vertical angles theorem. We can say that angle 1 and 2 are congruent and angle 3 and 4 are congruent because they are vertical angles. Now the next step, we've taken angle 1 and angle 2, and instead of saying they're congruent, we're saying they're equal to each other. Angle 3 and 4, instead of saying they're congruent, we're saying they're equal to each other. So remember, when you change the sign from congruent to equal, it's the definition of congruent. And before we said congruent segments, but now we're talking about angles. So it's the definition of congruent angles. Okay, number 4. 2 is equal to 4. So I'm going to look at the square above me, and I can see that the 3's are back to back, and I have 2 congruent to 4. So when you have two of the same thing back to back and you're left with the first and the third term, that's your transitive property. Okay, then in the next line, this 2 goes away and becomes a 1. And the reason we can replace this 2 with a 1 is because we said earlier that 2 is the same as 1. So I have substituted the 2 for a 1. And then finally we have set an equal sign, turned it into a congruent sign. So that is the definition of congruent angles. Okay, for our next proof, we have that angle 1 and 2 are supplementary. That was given to us. And then we have that the measure of angle 1 plus the measure of angle 2 equals 180. If 1 and 2 are supplementary, and then we take what supplementary means and put it into an equation, supplementary means two angles that add up to 180. All we've done is we've defined supplementary. So that's the definition of supplementary. Okay, when you have a set of angles that both equal 180, instead of saying that they both equal 180, we can say that they equal each other. So that is substitution. And then finally, angle 1 is still the same in the next line, but angle 2 has disappeared. Angle 3 stays the same in the next line, but angle 2 has disappeared. The only way to get rid of the same measure on both sides of an equation is if we were to subtract the same measure from both sides, and that's your subtraction property. Okay, so with vertical angles, you can have the definition of vertical angles. If I just say that angle 1 and 2 are vertical angles, I would call that the definition of vertical angles. Remember that vertical angles are located across from each other, they are congruent, and they are non-adjacent. They are formed by only two straight lines, so 1, 2. So if you have to highlight more than 2 lines in order to see that your vertical angles are across from each other, then they're not vertical. Okay, the reason that we're using the word theorem is anytime that we actually give the relationship. So if it's the definition, all I've done is defined that angle 1 and 2 are vertical. But if I say that angle 1 is congruent to angle 2, then it's called the vertical angles theorem. And that just says that angle 1 and 2 are congruent. So when we go to linear pairs, same thing. If I'm given a pair of angles that are linear, I can say angle 1 and 2 are linear. That would be the definition of linear pair. If I say that two angles are located next to each other, form a straight line, once again I would say that's the definition. But if I actually give the relationship, if I say that angle 1 and 2 are supplementary, or angle 1 and 3 are supplementary, then I'm using the postulate or the theorem. And then finally you have your definition of supplementary angles. So that's if in one line I say that they're supplementary, and then in the next line I put them into an equation. 1 and 3 are equal to 180.